editor. Document structure. The choice of internal representation for the document affects nearly every aspect of Lexi's design. All editing, formatting, displaying, and textual analysis will require traversing the representation. The way we organize this information will impact the design of the rest of the application. Formatting. How does Lexi actually arrange text and graphics into lines and columns? What objects are responsible for carrying out different formatting policies? How do those policies interact with the document's internal representation? Embellishing the user interface. Lexi's user interface includes scroll bar, borders, and drop shadows that embellish the document interface. Such embellishments are likely to change as Lexi's user interface evolves. Hence, it's important to be able to add and remove embellishments easily without affecting the rest of the applications. Supporting multiple look and feel standards. Lexi should adapt easily to different look and feel standards such as Motif and Presentation Manager without major modification. Supporting multiple Windows systems. Different look and feel standards are usually implemented on different Windows systems. Lexi's design should be as independent of the Windows system as possible. A document is ultimately just an arrangement of basic graphical elements such as characters, lines, polygons, and other shapes. These elements capture the total information content of the document, yet an author often views these elements not in graphical terms but in terms of the document's physical structure: lines, columns, figures, tables, and other substructures. In turn, these substructures have substructures of their own, and so on. Lexi's user interface should let users manipulate these substructures directly. For example, a user should be able to treat a diagram as a unit rather than as a collection of individual graphical primitives. The user should be able to refer to a table as a whole, not as an unstructured mass of text and graphics. That helps make the interface simple and intuitive. To give Lexi's implementation similar quantities, we will choose an internal representation that matches the document physical structure. In particular, the internal representation that matches the document's physical structure, maintaining the document's physical structure, that is the arrangement of text and graphics into lines and columns, tables, etc., presenting the document visually, mapping positions on the display to elements in the internal representation. This lets Lexi determine what the user is referring to when he points to something in the visual representation. These elements capture the total information content of the document, yet an author often views these elements not in graphical forms but in terms of documents' physical structure: lines, columns, figures, tables, and other substructures. In addition to these goals are some constraints. First, we should treat text and graphics uniformly. The application's interface lets the user embed the text within graphs freely and vice versa. We should avoid treating graphics as the special case of text or text as the special case of graphics. Otherwise, we will end up with redundant formatting and manipulation mechanism. One set of mechanisms should suffice for both text and graphics. Second, our implementation should not have to distinguish between the single elements and group of elements in the internal representation. Lexi should be able to treat simple and complex elements uniformly, thereby allowing arbitrarily complex documents. The 10th element in the line 5 of the column 2, for instance, could be a single character or an intricate diagram with many sub-elements. As long as we know this element can draw itself and specify its dimension, its complexity has no bearing on how and where it should appear on the page. Opposing the second constraint, however, is the need to analyze the text for such things as spelling errors. It makes little sense, for example, to check the spelling of the polygon or to hyphenate it. The internal representation design should take this and other potentially conflicting constraints into the account. One set of mechanisms should suffice for both text and graphics. Our implementation should not have to distinguish between single elements and group of elements in the internal representation. The 10th element in the line 5 of column 2, for instance, could be a single character or an intricate diagram with many sub-elements. As long as we know this element can draw itself, specify its dimension.